Okay, so it's been recorded. So let's resume on from Tuesday and talk about more about functional programming. And before we begin, there's a quick change in plan because I didn't realize that even though you have an account on System Skill, you need to know how to use Linux, which is which can be problematic if you haven't taken System Skill before. And I think at least 3 to 4 people here haven't taken the class before. So now all the assignments will be done locally on your machine. Basically, you can download IDE. I believe IntelliJ has a Scala extension where you can install and would be able to run Scala. You submit everything through Canvas. I already talked to our TA and he will be downloading these submissions and we'll be grading that locally on our machine. A quick caveat is, make sure you tell us if you have a weird setup or like if you need certain library to like run your program, right? So most of the time this is not needed. Most of the time, actually, our assignments will specifically tell you you need to use X and Y and Z for this question. You need to do certain things. You cannot use certain things so that it actually gets you to practice thinking about writing functional program in a functional way. Why is that the case? There are many support these days with functional programs that will imitate iterative programming or like one Neumann model. And because we are learning how to actually use functional programming, right? So we actually prevent you from using these additional libraries, basically. All right, so now if everything is done through Canvas, this basically avoids the problem of making sure you have to know shell before you can submit your assignments. So basically everything is submitted through Canvas. There'll be assignments. And the assignments will have a submission button. You submit and we'll grade it from there. All right, any question? No need to use System Skill or SysQ server anymore. But feel free to log in and test it on the server. All right, so if there's no more questions, let's do a quick recap, right? From lecture 1, I want to make sure you all like are aware of certain things that actually matter for the class. First is certain models when you I guess basically run the program. The first model is called one Neumann. One Neumann model is the common model where you have a stop program counter with the program counter or the instruction pointer point to here's the current line in your program, run this line, and then move to the next line, run this line, move to the next line, run this line. A little bit more background into this will expand in System Skill. If you haven't taken the class, if you took the class, you should know this already, which is your program is stored inside the memory. Basically, whenever you run any program, the kernel, the OS, actually copy the code in assembly down to the memory, and you run your program in Python, Java, line by line by line by line, right? And the fact that you run things line by line by line is called sequential instruction processing, right? And then we actually then talk about the Dataflow model, right? Where instead of having instruction being fetched and run in a control flow order, one line number 1, line number 2, line number 3, go to the main function, run the first line of the main function, run the second line of the main function. The Dataflow model is basically able to do this. You get the instruction in the Dataflow order. What does it mean? Whenever I have the input ready, I'm going to run it. If my input is not ready, I'll wait until the input becomes ready. It compute the operand, basically compute the operation like add, multiply, function calls, recursion calls, whenever you have the input, right? And there's no instruction pointer with this. Basically, there's no concept of the first line There's no concept of the last line. There's only the concept of, is there input data? Oh, I have the input data, I'm going to run it. And that's it, right? So ordering is based on what we call data flow dependence. What does it mean? It just basically means if I have my data, I can run it. If I don't have the data, I'll wait until I have the data and I'll run that function. Think of it as a math function, right? And many instructions can now execute at the same time, basically because if I have 5 function calls and all of those function calls already have its input, you can run all those 5 function calls in parallel, right? And this basically makes your program faster, right? And here's the comparison. If you have a sequential model to the left, the Dataflow model will be illustrated on the right side, right? Add and multiply, you already have A and B as an input. So you run both the add and multiply right away. And then it generates the input into the second add. The second add generates the input to the third add, and you got the results, right? And this is actually less natural. The one that's more natural as a programmer is the left one, the sequential one Neumann, right? That's why most of the programming language are asking you to do one Neumann, like C, C++, Java, Python, and many, many other things. And we actually conclude the class on Tuesday with a group exercise, which we are going to cover. So basically, I'm going to work through this at the end of this class. All right, so let's hold off to this for now. But basically, the question is, what does this do? And I appreciate, actually, I think as far as I checked this morning, there are 10 people already trying to work this out. Awesome. So for those who haven't really figured out what's going on, we're going to go through this in detail. In the future in class exercise, we are not going to give you the answer right away, right? So I'm going to ask you to do this. I really appreciate that you did. If it's a group exercise, we'll do this together, but most of them will be individual exercises. So go to the Discord session and ask the questions. So I think that's the only way you can learn, learning by doing. All right, so now that we talk about the recap of the first lecture, any questions before we dive into the basic of functional programming? All right, so if you have any questions, raise your hand or hit random emoticon, which I will not be able to tell who did that, but make it interactive, make it lively, right? Don't make the class too boring. It's already being sucky enough that we have the online format. I want to like minimize the confusions, the things that are likely to confuse you for the lecture, and I guarantee you, now that we start diving in, it'll be more and more confusing. So please, please, please stop me and let me know whenever you try to follow something. All right? Okay, so the first thing that you need to learn is what is an expression. Right? So what are the expressions? Expressions are something like this. If I write 10, right, the number 10 right here, what does it mean? It means this is a value. This expression 10 evaluates to the value 10 and will have a type of integer, right? It's a number. 12 plus 13, same thing here. It's the expression that evaluates. So this arrow sign, whenever I write this, basically it's like evaluate to, right? It's the expression that consists of 12, the operation add, and the number 13. These expression evaluates to 25. And again, it has a type of int, right? Be mindful about this word type, right? Each piece of expression, every expression should have its type, right? And you can bind a name to an expression. And an analogy of this is when you declare a variable, right? When you declare a variable, think of it that way, but don't assume that this is the same thing. It's kind of a little bit different in functional programming. What does it, okay, What's the English definition of define? Can someone tell me what's the English definition of the word define?
To establish an explanation on something.
Awesome. All right, so that's a great definition. And this is the same thing here. We are trying to establish the explanation of the word, I guess, the name here, the number, right? It gives the meaning. That's another great definition, right? It gives the meaning to something. Basically, when you do def number, what you're telling the computer is, I'm going to define what does number mean, right? I'll give you another analogy, right? Everyone here uses the internet, right? Okay, if you at this point never use an internet, but it's just not possible. What does it mean when I say www.google.com on the address? What does it mean? Basically, I'm trying to tell the computer, right? I want to access www.google.com. The main problem is, right? How do you know which computer your laptop should connect to actually access Google? Right? Because from the reality of things, right? The server at Google will have its own IP address, right? 10 dot something. It can be any number, right? It will be an IP address assigned to Google server that would be able to give you that search engine, right? And the fact that you can tell your computer saying, hey, I want to go to www.google.com, it means that somehow your computer has that definition. The definition that say this address maps to, well, no, this name, the www.google.com maps to this IP address, right? The same thing here. Def number equals 10 means that I'm going to name this thing called number, and number will have the value 10. And you could combine multiple expressions together because now, because you define number is 10, right? This number is going to evaluate to the number 10. This is another value, which is 10, right? So this whole thing is another expression that evaluate to, oh, sorry, I cannot write, to 100, right? Because it's 10 multiplied by 10. You can also do something like this. 3 multiplied by hello, right? Which means that this is a little bit odd, right? It's an expression. It doesn't always have to have a type. In the future, for this lecture, we will actually learn how to declare a new type or tell the computer, hey, we have a new type. How do you deal with it? But for now, let's actually first understand the concept of expression, because this becomes the basis of everything, right? To define an expression, this is called formally naming the expression. Think of it as a math function, right? You can call a cube that takes the input. So these, if you look at this code, these are all in the language called Scala. This is the thing that I asked you all to install on Tuesday. If you haven't done so, feel free to do it today as well. We have more time today. Basically, make sure you have Scala and you can run it by next Tuesday, because you start diving in deeper and use Scala actively. The code down here basically define a function called cube. The thing in parentheses. So if you write a function in Java and Python, what does a parenthesis do here? Because it's actually the same thing. I just want to make sure you're here. So anyone want to guess what does the x colon double mean in this parenthesis? What is x? So what is x here? It's the parameters. It's an input, right? It's an input to the function cube. So if I say cube 3, it knows that, okay, now x is 3, right? And the thing after that, the def e cube equal something, 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 it looks a little bit less like a Java function, right? And it's more like a math function. You see, it's more like a math function now, right? All right, someone is typing, so I'm gonna wait. Well, I mean, let me go ahead, but keep typing. If you want me to hold off and go slower, please do let me know. The one downside of online classes, because I have no idea whether you're with me or not with me. In a real class, in a physical setting, I can look at your eyes like no one is with me. I need to slow down. This setup is harder, so you need to let me know. Help me on that a little bit, please. But if I need to go slower, please let me know. If you want me to go faster, that's okay too. But I think I already, like, typically I said, like, I speak really fast, right? So I think, okay, someone left the chat. All right. So basically, with this example, you see that you can define a function called cube, right? The name is cube. It takes one input. The input type is a double. And what you do is multiply x 3 times, return that. Basically, you can then define another function that use the already declared function, because you already know what cube is, right? So now you can say sum of square cube. The SSC stands for sum of square cube. Takes to input x and y. It returns cube of x and cubed of y, right? So that's it, basically how you can define a function. Look at this keyword, def. In Scala, when you said def, it means you want to define something. You define a name, and a name will be tied to some expression, right? Again, def, you define a name, which can be any name you want, and you tie that to an expression. It basically will map the name to an expression. An expression has value. It evaluates to the value. Again, stress on the word evaluate to a value. Over here, this expression, eventually, once you know x, it will evaluate to some value, right? So how do we evaluate? There are multiple models. So today will be a little bit boring. It's a lot of like formal definition, but it will be the basis of functional programming. The first model is called substitution model. What does it mean? So when you want to evaluate an expression, trying to figure out what is the value of that function, you can use this substitution model. What does substitution mean? Here's an example. Assume that we define f that takes n as an input, and we do n multiplied by n. And we want to evaluate f of 2 plus 1, right? So the substitution model would do this. First, you would then evaluate 2 plus 1. That's the first thing you see, so evaluate it first. That evaluates to 3, right? And then every time we see f, right, we see f as an expression, we will then replace the input of f, which now we know is 3. So f of 2 plus 1, you just replace 2 plus 1 with 3. That's the first substitution. And what is f? F is n multiplied by n, right? And you know now that n is 3. So you actually, this side, what I just write here, it means that n left arrow 3 means I'm going to put the value 3 into n. I'm going to substitute n with 3, right? Any questions so far? Basically, n left arrow 3 means that I'm going to substitute n with the value 3. So what will happen if I substitute n multiplied by n? with 3. You're gonna get 3 multiplied by 3. Eventually becomes 9, right? Anyone here heard about the halting problem? Which is actually a classic problem. Halting problem. It basically means that can you determine if your program will eventually terminate, stop, and got a value, right? Or you're gonna stuck in some infinite loop, right? So that same thing kind of applies here, right? Because how can you know that eventually you're gonna get a value? How can you know that your evaluation terminates, right? So if everything is a function, when does the evaluation of f, right, reduce to a value? Because you want to actually, I mean, for a computer program to be useful, eventually when you stop running, you get an output, right? The basis of why we want a computer, right? Why, okay, let me rephrase it this way. Why the heck do we want to learn all this thing? Because when you use a computer, you put an input, you expect an output, right? Let's say you're playing Dota 2. You click on something, you click the ultimate skill. You expect the character to actually use the ultimate skill and kill the opponent, right? So that you win. Unless you get so pissed with your friends in the team and you want to throw away your life at a fountain and you like basically feed them, right? Again, still you have an input, it generates certain output. Same thing here. You want to see the termination of your function. But the question is, does every expression reduce to a value in finite step, right? And I'll give you a little bit more like a real world example, right? Anyone remember the, what was it? I think it's called Taishana, where people sign up to get like money from the government. And I think the first day of its launching, right, it crashed. The server crashed, right? So if you go to the website, try to enroll, right? You're gonna get a timeout. What does timeout mean? So let's say you go to Google Chrome, you go to certain website, and I'll use another example. Sometimes Facebook goes down or Google goes down for like 10 minutes. It will be a big news everywhere because everyone needs Google services, right? But what are you gonna see when something goes down? Anyone remember that dinosaur that said something timeout and you just basically play that dinosaur game in Google Chrome? Are you still with me? Yep, the dinosaur game, right? What does it really mean in terms of termination? When you go to a website, it basically tries to establish the connection between your computer to the server, right? So they can send the website content to your computer. That dinosaur things basically mean that I send a packet over. It doesn't really give me anything back, right? You're staring at a void. You got nothing. And at some point, Google Chrome is like, okay, I wait enough time out because I can't establish a connection. This is likely some weird address that I cannot really ping. Right? I can't really like go to them. So that's an analogy here. It's not like a formal exact same thing, but your function call might not terminate in finite step. So let's look at something that looks confusing here, but we can declare it this way. You can go to Scala and do this. What does this mean? You define a name called loop. What does loop return? What does loop return here? Is an int? Yes. Awesome. What is the value of that int? Yep, the loop itself, which is kind of odd, but you can define it this way because we just bind. Basically, we bind this name called loop. And We just define that, hey, loop will return loop. Yay, fun, right? The loop will have the type of int, but if you look at this closely, it will never terminate. If you call loop, yep, your computer will try to evaluate loop, and it will keep evaluating itself, which return loop, right? So this never terminates. So if we use our substitution model, it's going to replace loop, because substitution model will replace something that you know with the value. Do we know loop? Yes. What's the definition of loop? Loop. So it will replace loop with loop, and this go on indefinitely, right? So not every expression will reduce to a value in a finite step. So what does it mean? We have the substitution model, which will run into this problem. So let's look at a different strategy. Another evaluation strategy, which hopefully maybe can address this problem a little bit. It's not to fully address the problem, but let's look at another strategy. So far, we look at the substitution model to evaluate expression, right? So let's experiment. Let's try something new, right? So the idea in this case, instead of substitution things right away, you pass the arguments into the function right away without reducing them, right? Without reducing them. So earlier with the substitution model, the first thing we do, remember, we do 2 plus 1. Oh, but let's evaluate this, and we get 3. Now, let's use a different strategy. We see f of 2 plus 1. F of 2 plus 1. Instead of evaluating 2 plus 1 into 3, we replace n with 2 plus 1. So over here, you get 2 plus 1 multiplied by 2 plus 1. And you basically realize, well, it yields the same result, which is 9, right? Because both of these, well, f of 2 plus 1 will terminate, right? So this evaluation strategy would yield the same results. Why? Because our computation has no side effects. What does side effect mean? It can be things like someone hit the power off button, right? Okay, let me ask you one thing, right? If you're running your machine and suddenly your cat happened to just headbutt the power button, what will happen? That's something my cat haven't done yet, but it's possible actually. But yeah, what if I was playing games and my cat decided to headbutt the power button? Computer go black, yes. The reason why that happened from the system point of view is that that power button is tied to a signal. Basically, you give a signal. It's actually called sig kill, kill the computer, right? So it tells the computer to close everything. That's side effects because somehow it interrupts the running of your program. It interrupts like the running of everything you're running right now, right? So the reason why the strategy yields the same result as long as there's no side effect, or as long as the function doesn't have the side effects, because it's the order here of when you do the substitution versus reduction, it doesn't really affect the final results, right? So we can think of it this way. Now you have two styles of calling a function. The first styles, both are substitution, right? But the first style is you reduce first, which means that if you see f of 2 plus 1, the first thing you do is you do 2 plus 1 into f of 3. So that you go to 3 multiplied by 3. That's call by value. Call by name is you substitute first and then reduce. You have f of 2 plus 1. You then substitute 2 plus 1 into n. So you get 2 plus 1 multiplied by 2 plus 1, which again both equal 9, right? So reduce means you're going to evaluate the expression you know. Substitution means if you have a function call, you replace the variable, the name, with the expression, right? Substitute means that you're going to replace a name with the expression. Reduce means you're going to evaluate the expression. That's basically the difference. And both strategy should evaluate to the same final value if both terminate. If both terminate. And there's a little bit of a theorem between call by value and call by name. Okay, I'm going to go back to the same slide so that we can remember. Call by value is you reduce first, then substitute. You get everything into the value. The trick here is call by value, get everything into the value, then replace and substitute the name. You go value first, then substitute the name. Call by name, substitute the name first. You see a name variable, you replace that with some expression, then you reduce the expression later. So the theorem here is both strategy would reduce to the same final value as long as there's no side effects, and both terminate. There's no weird loop in the middle. Furthermore, if call by value terminate, it means that call by name will also terminate. The other direction is not true. So if call by name terminate, call by value might not. I actually can give you a reason as an example here. Let's say I have f of x that equals 10. It has nothing to do with x, right? And I said not dev, but if I say x is take the value loop, which one terminate? Which one will terminate here? F of x is return 10, and then x is a loop. Let me refresh this question. If I do call by name, what will happen? If I do call by name, I see f of x equal 10. I'm going to then do f of loop equals 10, and I'm going to return 10, right? Because it doesn't really try to evaluate loop. It would try to replace the occurrence of x in my function, and there's no x here, so loop is gone. I return 10. If I use call by value, the first thing I do is, okay, what's x? What's the value of x? Loop. What's the value of loop? Loop, 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 loop. So it will never get to the phase where what's the value of f of loop, right? Any questions so far? Because it feels like this might be confusing for you. Okay, raise your hand if this is confusing. Okay, no one raised their hand. Okay, yes. Okay, someone raised their hand, so good. So if I have f of x, right, equals 10, if I do call by name, right, call by name, I'll go look at f of x. What is f of x? What is f of x? What does f of x evaluate to? 10, right? You replace, you go and look at either x here. If I find x here, I'm going to replace x with whatever x maps to. But since my function doesn't have any occurrence of x, so we just say that's 10. If I do call by value, the first thing I have to do is evaluate x. So what is x? X is loop, right? So it means that I'm going to have to first evaluate loop. And then you're stuck because you can't evaluate loop. That never terminates. So it means that if call by name terminate, call by value might not. This is the counter example of that, right? Call by value, basically every function argument is evaluated once because you do that at the beginning. For call by name, you delay that evaluation. If that is unused in the function body, that's gone. So by default, the language that you're using is called by value, right? So hopefully, if it's still confusing, let's go through some example that is more concrete, right? So let's play around with this a little bit. Consider this: def CBV x in y in equals x, and CBN called by name. So the difference here is when I have this colon arrow sign, it means that I tell scalar to delay the evaluation of x. Replace whatever x inside my function first, then evaluate it later. That's why in default case, which is this, it's called by value. By default, scalar is called by value. But if you put the equal arrow, like equal greater than sign, which is this arrow sign, it becomes called by name. Then you define loop is loop. And let me do this. What will happen? So I'm going to give all of you here about like 5 minutes to think about this. What will happen? Let's try to call the two version with left CBV 1 plus 1 and loop, or left CBV loop and 1 plus 1. Anyone, let's go one by one. And the easiest one is, for these two, will that terminate? Which one of these four will terminate? Nope, right? Because it returns x, which is the first input, and the first input is a loop. So none of these will terminate. None of these will terminate. So I'm going to cross this off for now. Any question here? All right, raise your hand if you have a question so that we can pause and address all the questions. All right, so now let's do a little bit tricky one. So what will happen if I have left CBV 1 plus 1 and loop, right? So what's the first thing called by value do? If I have this expression and I want to evaluate it, what will happen here? It would, yes, it would first reduce, right? What does reduce do? It try to figure out for these two inputs, what's the value of that? So what's the value of 1 plus 1? 2. Yep. So this returns 2. What's the value of loop? So what's the value of loop? And basically, the computer will keep asking, what's the value of loop? Forever, sadly, into the abyss, right? And it basically, now you see, if you run this left CBV 1 plus 1 loop, it will never stop. Yay, right? So this thing also doesn't evaluate because it never terminates. How about the left CBN 1 plus 1 loop? So let me use a different ink color. So left CBN 1 plus 1 and loop. So what's the first thing call by name do? You do substitution, which is you go look at this definition, right? You look at this definition and say, okay, I'm going to go look at that definition. I'm going to replace x with whatever is the first input, which is this guy, right? So this will equal to what? Well, it's equal to 1 plus 1, right? Because basically I took this, replace it here, right? So what does left CBN return? It returns 2. why does loop gone? Why is there no occurrence of loop anymore? Yep, because when we apply substitution, we never use loop inside the function, so it gets thrown away. Yay, right? So you can see that in this case, you just get rid of all the loop, right? Because they never get used. So that's why if call by name terminate, it doesn't have to be the case that call by value terminate as well. And this is an example. But the other way around, if my call by value version terminate, it means that call by name will terminate. There's also sorry about that. That was from about 2 classes ago of this. I forgot to erase them. So sorry about that. Basically it means something is going to appear there. There's also condition that you can use. Anyone here remember if else in C, Java, Python? It's pretty useful, right? We need to use it to control if it's this true, you do this. If it's not, do something else. So the same thing is being offered in functional programming, right? It's kind of like the same as when you write a math function f of n equals 5 if n is less than 0, equals 10 if s is 0, and equals 15 if n is greater than 0. This is condition, exactly the same thing, right? This is basically how you can define the value of f of n. So we apply that to functional programming. Scala gives you that option. So you can use if else, right? So the way it works is this. You have def function name. Input is the same thing. If x is less than 0 or equal to 0, you return negative x, else x. What does the function do? What does this function do? The function name might give you some hints. Always make x positive. What's the formal name for that? Absolute value of x. This thank you for making me aware that when it's afternoon time, everyone's brain can be fried, including myself. So it's find the absolute value of x, right? Again, if I have to slow down because your brain is fried, it's totally okay. Let me know. And I appreciate these like more often like question and answer. I think it's more fun, at least from my side. So using the same construct, right? We can kind of formally define if else by saying this. If we have if E1, E2, and E3, these are expression, right? This whole thing behaves like this. If E1 is true, you are going to return E2. If E1 is false, you return E3. Basically, same as the mass function that we've seen before. So here's a little bit more of the example. So let's evaluate absolute of -40 and do it like really, really slowly using the substitution model. You know that x is 40, you have this expression if x is less than 0, negative x, else x. And you are going to replace x with -40. So you apply that everywhere. It becomes if this, return this or this. Then what's the next step? You evaluate the next thing that you can evaluate, which is, this, right? What does that expression return? -40 less or equal to 0. What does that expression return? It returns true or false, right? In this case, is it true or is it false? is true, right? As you can see from the next line. So if true, negative 40, else negative 40. So are you going to return the negative 40 or negative 40? You're going to pick this one, right? So you basically return this, evaluate to 40. Absolute of 5, almost the same thing, except this time you got false out of the condition, which in this case, then you're going to evaluate to just the latter half of the else, which is 5, right? So something more complex. What if you have this? Again, our old friend loop. And a goofy function, x int, if x is less than 0, loop, else 10. Right? What will happen if we run goof of 1 versus goof of -1? And remember, these are both called by value. These are both called by value. So call by value will do what? Evaluate first, yes. So it evaluate 1 and -1, right? So you then see if x is less than 0, right? For this part, this will return what? Is it true or false? Which one is true? Which one is false? Yep, so this is false and this is true. Right? So this would just never terminate because it evaluated to a loop, but you got 10 for here. Right? So now you can construct an if-else statement that can sometimes terminate and sometimes not, right? Because you can define this weird loop thing. Okay, so another quick thing I have to cover is Boolean, true or false, right? You can you can do reduction on these Boolean expression, true or false. And this basically takes two basic values, true and false. Right? So the evaluation of the expression will follow the normal logic operation, which is not true is false, not false is true. True and the double and here is and. True and expression is an expression. True or expression is true. Not false is true. False and expression is false. False or expression is expression. It's the same as a logic. Anyone here familiar with the and or logic? Anyone here not? Anyone here want me to explain what does and or do in programming? Please raise your hand. I'll give you 10 more seconds. Okay, so hopefully these are pretty straightforward. I just want to make sure it's there so you can actually use it, basically. So now let's actually formally define what does def do. The keyword def in Scala basically bind the expression to a name. What is the name? So what's the English meaning for name? Actually, that's kind of tough to define what does name mean. Basically, it means that I give something some meaning, right? Thank you. Basically, it's a word or set of words by which a person, animal, places, or things is known, addressed, or referred to. That's another perfect dictionary meaning for the word name, and it applies here, right? Now you can bind something, the expression into a set of words, right? So fundamentally, def is a by name type, right? Which means that the right hand of the expression is not evaluated until you use it. If you want to use the by value, use the word val. What does it actually mean? Now, it might sound a little bit confusing. By name type means that if I have foo of 1, foo of 1 will never give you 11 until you call it. Basically, unless you call foo of 1 in your program, it will not give you 11. It will give you 11 only when you call this. That's why it's by name. If you use val foo2 equals 11, by this point, foo2 will take the value 11. It just replaces foo2 with 11. So any questions here? Because it feels like this might be a little bit confusing. So let's actually do some example, right? So let's suppose x and y are Boolean, true or false. And we want to simulate AND and OR, right? So remember that they are short circuit, which means that if you have false and loop, you get false. Right? If you have false and loop, it will return false. So let's answer this. Def version of this, right? Def x Boolean y Boolean if x y then if x y else false, right? Will this terminate if I put let's do the AND first, right? If this is loop and this is true, will this terminate? Nope, you're correct. What if I change this to false? If I define it this way, will I be able to terminate? It will not, right? Because the first thing you do here is if x. So we'll say, hey, what's loop, right? It will terminate only if this is false. And this can be loop, this can be true, and this can be false, right? In that case, you can short circuit this. Another thing is you can call nested function as well, something like this. Def sum of square x and y, right? And then you said inside the function, you define another function called square. Take an input t and return t multiplied by t. And sum of square will return square x and square y. So a little bit special thing about scalar, the line before this in bracket, this is a return value. Basically, that last line is the return value. Why do we do this? This actually helps a little bit with what we call namespace pollution. So if you do object-oriented programming, you might have realized what does the word namespace mean. It basically means that if I define a variable called dog and cat, right, and later I want to use another variable, but I cannot now name it dog and cat. So in this case, it's the same thing. if I define sum of square and SQR in the same level without using nested function, outside of this, everyone will know sum of square, everyone will know SQR, and you can't rename something to SQR. In this case, with the nested function, SQR is only seen inside sum of square. So if someone accidentally type SQR outside of this function, the compiler will yell at you saying, hey, I don't know what SQR is, right? And again, as I said, notice that the last statement of this bracket is the return value. Another thing I kind of need to then talk about it is what a concept of block, right? Which is the basically this bracket thing, right? So the following, which is have the beginning and the end bracket, is val number 10, number plus 1. These basically evaluate to 11. Why? Because the end of the block is the return value. That's what this whole expression evaluates to. So if you can extend this idea, you can use this block and assign it to a name. Now you have a name called foo. What does foo do? Inside this block, what does it evaluate to? It evaluates to this last line of this block, which is 10 plus 1 and equals 11. So this basically binds foo to the expression inside the braces. All right. Another thing we need to tell so that we can use scalar is something called visibility. Basically, if you define something inside a block, which is this curly bracket, anything inside the block is only visible inside the block. Outside of it, no one knows what they mean. Definition inside the shadow thing is defined outside the block, something like this. If I do val x equal 5, and then inside the value result, I have val x equals 6, x plus 1. What will get print here? Basically, I say print line x, print line results. What will get print? By the way, print line in Scala would print this thing on the monitor. So what do we get? Are we getting 5, 6? Are we getting 6, 6? Are we getting what? Exactly. You get 5 and 7. Why? Basically, inside the context of results, right? You redeclare x to be 6. And then you add 1 to that and return. So that becomes 7. So results is 7. X outside of that braces is still 5 because no one knows the x inside results. All right. So in our honestly, I think today that's it for the content for the class. So we go back to that data flow things and we'll going to work through that. But right now, before we leave today, make sure you have Scalar. Please install it right now. Basically, after we go through the in-class exercise, we will actually look at how to install Scalar, how to make sure you can run the following code. Basically, I already posted a PDF of the slides on Canvas, so you can copy the code and try it out. This should print hello world. Why do I ask you to do this? Make sure you can run it. Basically, make sure you have something that you can follow and do the future in-class exercises. Any questions so far before I move back to here? Oh, okay. The arrow sign here. Okay. Let me use this as a scratch pad. This thing will force. So what's the default mode for def? Is it called by value or called by name? The default is called by value, actually. The default is called by value. The arrow sign will force it to be called by name. All right. Now you're making me not sure if that's the case. Let me. Yep. Here, scalar is called by name, called by value by default. If you want call by name, you put in this arrow sign. All right. Will the function that JOT, what does JOT mean? Sorry, it might be the typo. So can you? Oh, okay. Will the function that not terminate give error? If I recall correctly, in Scala, it would give you an error saying, hey, this doesn't terminate, do something with it. If I remember correctly, but I might be wrong. It's either you just have an infinite loop or it will not let you run. But I think it will not let you run. We can play around with this once in the next class when we all have Scala set up, actually. Or you can play it now, actually, after we go through this. So how about we give everyone maybe 4 minutes break until 1:10, and we'll come back to this group exercise. That's okay? Because I think I need a little bit more coffee. All right, so let's do a quick 5 minutes break. We'll be back right now. It's 1:07, so we'll be back at 1:12, and we will all go through this together. All right. All right, so see you all in 5 minutes. All right, are you all back? Okay, so let me assume that people are back. So for those who did this already, anyone want to take a guess of what this program do? Any guess? Ah, yes, you got the correct answer. It's a Hamming distance. So I'm sure for those who are just typing, it's an explanation of what Hamming distance do. So please keep typing so you actually discussed it. No, don't delete what you're typing. Because it's probably correct. Yes, it's the number of ones after the XOR, right? Or another definition, counts the number of different bits between A and B. All of these are correct. All of these are correct. So the reason why this is called Hamming distance is this is actually discovered by Richard Hamming. It's being used in computer science, especially in the context of security, when it comes to when you want to send a signal from one place to another. Because when you send data over, you need to figure out what's the Hamming distance. And it has some connotation with security. And see if bits are flipped. Right? So if bits are flipped, it basically what it does is it's the number of bits, or I guess this is the number of bit flips that you have to do to make A becomes B. That's why we call it Hamming distance. Richard Hamming has a lot of works that are related to playing with bits, right? The other really high impact work that he did was is called error correction code. It's called Hamming code, which allow you to correct the bit inside DRAM. And we actually use something similar for server nowadays, right? It will make sure your DRAM would be more reliable, and you're more, I guess, you're less likely to run into blue screen on Windows. It's just many cases of blue screen happens because somehow your DRAM flipped the bit from 1 to 0, and Windows like, I don't know what that value is. It means nothing to me, so I'm gonna crash myself and reboot. Hamming distance, why is this a Hamming distance? So if you look at this, the first thing you do is A XOR B, right? What does XOR do? XOR basically would count, not counting per se, but it would produce ones if the bits of A and B are different. So let's say A and B have 5 bits, and all the 5 bits are different. The result of A XOR B would be 1, 1, 1, 1, 1. If all of them are the same except for the last bit, then A XOR B would be 0, 0, 0, 0, 1. If the bit is with the most significant bits is different, the rest are the same, the result will be 1, 0, 0, 0, 0, right? So from this point on, you basically forward the results, copy them to both sides. So this is A XOR B and A XOR B. Then we check, right? Basically, the next thing we do is we check if that's 0. If it's 0, you stop, terminate, and you return 0, right? The left side here on Tuesday, sorry, I was about to say Monday. On Tuesday, we already established this is some kind of a counter. It starts from 0 and count up whenever you have to loop one time. When do we have to loop? Basically, when we have to loop, it's when we go through this again. So we keep going through this loop until the results here return. The result of this becomes 0. It would trigger through through both paths, right? True and true. That's when it will stop. So let's say you do AX or B. Let's say you do AX or B, right? It would copy the value. Let's say AX or B is 1100, right? You then copy 1100 on both sides. This is 1100. What's 1100 minus 1? 1011. Yes, perfect. 1011. What is 1100 and 1011? So if we just extract, so let me change another color here. So if we just focus on this part, right? This part. What does the green part do? What does the green part do? Remove, basically, yes. It removes one of the least significant ones bit. So let's say input is 111001. This would basically remove this bit. It makes it 0. If the input is 111010, it basically removes this bit, make it make it 0. It basically removes that last one, right? And it loop back. Basically, the output here loop back to here. So what will happen when you have to iterate to this loop one time? What happened? You lose one of the ones. So let's say there are 5 ones in your number, right? In your AX or B, result in 5 of the ones. You go one time, you have 4 of the ones. You go one more time, you get 3 of the ones. You go one more time, you get 2 of the ones. So in this case, basically, it performs population count. We call this population count. It counts the number of ones in your data. Any questions so far? Basically, that's it. The whole thing is counting the number of ones in AX or B, or sometimes we call this Hamming distance. If you are curious, you can, and there's a good Wikipedia articles on the use of Hamming distance as well as what they are. If you are more curious about that afterward, feel free to ping me. I can basically extend this into more things. All right, so any questions so far before we move to let's install Scala? Okay, so if there's no more question, we already did the solution for in class. So don't forget to put this answer on the in class exercise 3 points. Why not, right? Say Hamming distance. If you still have question, why is this a Hamming distance? Feel free to let me know. For now, let me stop the recording so that the YouTube video is not going to be too long because we will then go to Discord. So let me stop this recording real quick.